Let's do another example where we find all the zeros of a polynomial. We'll do several of these examples, and it'll help you the more you see it done. Here is a polynomial, highest degree 4. So we're looking for 4 zeros because the degree tells us exactly how many zeros we need to find. We're going to use our calculator to help us find our easy zeros. I have it plugged in. I'm going to go and look at the graph. So here is the graph of this function. And, well, let's see what we got here. It looks like it could be 0, maybe 1, 2, 3, 4. Let's go to our table. And I am going to 0, 1, 4 was not 1. So I'm going to write down the easy zeros. So the easy zeros are x equals 0 and x equals 1. And it looks like that's all I can find, but all I need is 2 to bring this down to a quadratic. Remember, every time we do synthetic division, we're going to bring it down by 1 degree. So let's start doing synthetic division, and we can use 0, but we really don't need to. If you kind of look at these, every single one of these has an x in it, so we can factor that x out, and that's going to be the x equals 0. I'm going to go ahead and do that. If I factor x out, I end up with x cubed minus 5x squared plus 3x plus 1. And this is one of my factors, so I can just work with this guy in here. So I've already used that x equals 0 because that's right there. So I'm going to use synthetic division with the x equals 1. So here's the half box. I'll put my 0 on the outside, and I will list my leading coefficients. I want to make sure I don't have a missing term, and I do not, and so then I'm just going to write out my leading coefficients. First coefficient is 1, then -5, then +3, then +1. I'm going to bring down my first term. 1 times 1 is 1. Add down and I get -4. -4 times 1 is -4. Add down and I get -1. -1 times 1 is -1. Add down and I get 0. If you don't get 0 here, you've done something wrong. You either found your zeros in your calculator wrong or you've done some math wrong, because our remainder should be 0 if we find a 0 out of our calculator. Right here, we have a new polynomial, and I'm going to just go ahead and do quadratic formula every time. It just makes my life easier. And if you remember the quadratic formula, it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. If you don't know that, you should become familiar with it. It's one of those formulas that you should know. Not too many do I think you really need to memorize, but that one is one of them. Now, what does the A, the B, and the C stand for? Well, if you think about the standard form of a quadratic, you'll remember it is ax squared plus bx plus c. And when we're solving quadratics, we set that equal to 0. Right here is your A. Right here is your B, and right here is your C. You could write it out if you wanted, and you could write this as a quadratic, and it would be x squared minus 4x minus 1, but then you would need to pull out the A, the B, and the C to plug in the quadratic formula. Once you get good at this, you'll start just seeing that that's A, B, and C, and you can go ahead and use the quadratic formula. Okay, so x equals -b. Here we go. X equals -b, -4, plus or minus the square root of b squared. So that's negative 4 squared minus 4 times A times C, all over 2 times A. 2 times A, and that's 1. As you move forward, you can do some of this in your head, and I suggest you do. You never want to put the whole thing in your calculator at one time. It's just going to mess you up. So let's clean it up a little in our head, and then we can go to our calculator, and I'll show you how. So negative 4, that's positive 4, plus or minus the square root. Negative 4 squared is 16. Please be careful if you put this in your calculator and put it in parentheses. It's much better to just square a number in your head and you won't mess it up. Most of you know that a negative times a negative is a positive, or a negative number squared is a positive. So negative 4 squared is 16. And then negative 1 times positive 1 is negative 1, times negative 4 is positive 4, all over 2 times 1, which is 2. Now, if you needed to, you could use your calculator to help you simplify what is under the radical, but do not put the radical in your calculator. So let's clean this up one more step. 4 plus or minus the square root of 20, all over 2. You should have reviewed simplifying radicals, and we're going to want to simplify this radical. So we're going to say 4 plus or minus. Now square root of 20 right here is, and I'm going to use a little space over here, square root of 20 is 4 times 5. The reason I chose 4 times 5 is 4 is a perfect square, and I can take that square root and simplify it. So the square root of 4 is 2. I cannot take the square root of 5. All of that stays over 2. And now you're ready to reduce. This 2 on the denominator goes with both of these terms. So the only way you can reduce or simplify is that all of them are divisible by a single number. And the 4 and the 2 are both divisible by 2. So we can say that this equals 2, 4 divided by 2, plus or minus 2 divided by 2 is 1. So that is just the square root of 5. And that is actually 2 zeros, because it is 2 plus square root of 5 and 2 minus square root of 5. They will always come in pairs. A final list of all the zeros are the 2 we found in our calculator. So x equals 0, x equals 1, 2 plus the square root of 5, and 2 minus the square root of 5. You should have the same number of zeros as your degree, and we do. Our degree is 4. 1, 2, 3, 4.